Hello and welcome to another section in further maths. Today we'll be talking about the quotient rule. We are still in the spirit of differentiation. In this section, we'll be concentrating more on rule of division. But before that, let us review our previous lesson. Okay, welcome back and thank you. Now, when we're talking about differentiation, we've done justice to the product rule, multiplication and addition of some of the differential coefficients. Today we'll be laying more emphasis on a quotient rule. Now, when you talk about quotient rule, it talks about differentiating a function that is of the form u all over v. At this point, when you want to differentiate a fraction, you make use of the quotient rule. So when you're doing that of a quotient rule, and a constant term, we stated it in our first lesson in calculus, that we proved it that when you're differentiating a fraction, the differential coefficient is usually v du dx minus u dv dx all over v square. So this is called quotient rule. This is the quotient rule that governs differentiation. So each time you want to differentiate a fraction that contains two different digits, you make use of this rule, and it's called the quotient rule. Now let's go into detailed application of the quotient rule. Let's say, for example, if y is equals let's say it's sine 3x over x plus 1. You can see the question came in a different format from what we've been seeing before now. You have to differentiate this and differentiate this. But remember the rule that governs quotient rule. Y equals u over v. When you have y equals u over v, you now do dy dx is equals v dv du dx. This is du dx. Don't be confused. This is du dx. V du dx and u, this is dv dx. So let's say this is our u and this is our v. So if u is equals sine 3x, what's the value of du dx? Because it's needed here. So our du dx, I told you, is 3 cos 3x, applying the differentiation of trigonometric identity. If you differentiate sine, you have cos. If you differentiate cos, you have sine. But remember to bring out this, the only parameter that is attached to it, to the back side of it. Then you write whatever thing you have, the cos 3x. So du dx is equals to 3 cos 3x. Now our value of v is equals, from here, x plus 1. The value of our dv dx will now be equals, when you differentiate this, remember it's raised to power 1. Let's apply the rule of differentiation. Always note it at the corner. The rule of differentiation is n x to the power n minus 1. This will just serve as a guideline. So let's apply it here. Our n is 1, so you bring it back, 1 x to the power 1 minus 1 plus, remember constant term is 0, so x to the power s1 is 1 times, this is x to the power 0, which is 1. You know the law of indices, if a number is raised to power 0 is equal to 1, so this is 1, so which is equal to 1. dv dx is 1. Now let's come back to our quotient rule. So our value for dy dx, dy dx will be equals, let's start taking down the parameters. V, what was our v? X plus 1. We put it here, x plus 1, and what? Du dx. What's the value of our du dx? Du dx, we got 3 cos 3x times 3 cos 3x. You're done with that. Minus, what's the value of our u? u is sine 3x. You put it down here, sine 3x. Then what else? dv dx. dv dx is 1, so this is times 1, which is the same thing as sine 3x. Now we go further by putting all over. Our v square is what? V is x plus 1 all square. So we now have x plus 1 all squared. This is the formula v squared. Now let's continue. Let's expand this if you want us to get this. So we now have this times this is now x plus 1 3 cos 3x minus sine 3x all over x plus 1 all square. I don't think there's any other way to break it down, so we are supposed to stop here. So if you have y, if y equals to sine 3x over x plus 1 is given to you, then find dy dx. The value of your dy dx is equals x plus 1 in bracket 3 cos 3x minus sine 3x all over x plus 1 all squared. So I would still like us to try another question so that we increase our level of familiarity with the quotient rule. So let's go into question 2. Let's try an exponential differentiation. So if you have ln x all over e raised to power 2x being equal to y, then find dy dx. Remember, it's a quotient rule that you need if you have something like this. So you know that dy, state your rule. I'm stating the quotient rule now is equals, for guidance, is equals v du dx minus u dv vx all over v square. And don't forget the simple rule in differentiation that states nx minus 1. These rules will always guide you. So let's start. From this, we know that our u is equals to ln x. So du dx of ln x is 1 over x. We proved it in our previous lesson that du dx is equal to ln x. The differential coefficient of ln x equals to 1 over x. Then you do v equal to e raised to power 2x. Then at this point, dv dx would now be equal to 2 e raised to power 2x. You differentiate this, multiply it by this. So if you differentiate this, you have 2 times this, which is 2x. So from this, let's go back to our master equation. Remember, this is our master equation. So let's go back and say dy dx is equals to, let's start taking down the parameters. Our v was what? E raised to power 2x. Bring it out here. E raised to power 2x times du dx. Du dx, we got 1 over x times 1 over x minus our u is ln x, the ln of x, and our dv dx, whereas dv dx is 2, that is times 2 e raised to power 2x all over our v is what? V is e raised to power 2x all squared. So I think we are gradually progressing. So with this, we now have what's common between this and this is e raised to power 2x. So dy dx becomes, we have e 2x, then in bracket 1 over x minus, it now become ln, because it is, it becomes 2 ln x all over e raised to power 2x. 2 times 2 here is 4, becomes e raised to power 4x. So if you're being given y, if ln x over e exponential of 2x is equals to y, find dy dx. The dy dx of this equation is e raised to power 2x in bracket 1 over x minus 2 ln x over e raised to power 4. I would like to say a big thank you to you for joining us in this lesson. It's really a nice time and a great day having you around. But in order for you to refresh your memory on what we've just discussed, please always take the test that will appear on your screen, and do well to use the lesson notes on the platform for a better information on the topic we've discussed. Feel free to always drop your questions, your contributions on the comment section. We'll be very glad to hear from you. Thank you.